All right, today we're diving into something pretty wild. A new AI model that's so incredibly powerful, its most important safety feature isn't something it can do, it's something it can't seem to control. Yeah, you heard that right. Let's get into it.
So picture this, March 5th, 2026, OpenAI drops their new model GPT-5.4. And this wasn't just, another incremental update. Nope, this was a massive leap forward, especially in a couple of really key areas. It basically rewrote the rules for what we thought AI was capable of.
First up, they tested it on the kind of work that, well, professionals do every single day. Think high-level knowledge work. And the score? A jaw-dropping 83%.
And if that wasn't enough, they tested its ability to actually use a computer. We're talking mouse, keyboard, the whole shebang, just like you or me. It scored 75%. Now get this, that's the first time an AI has ever officially surpassed the average human at just using a computer.
So naturally, all the headlines were screaming about its power. But honestly, the most interesting part of this whole story, the part that has these massive implications for AI safety, it's a surprising weakness. It's a flaw that might actually be our best line of defense. Kind of weird, right?
Okay, so first things first. Let's really wrap our heads around just how capable this thing is. We'll start with how it performs in the professional world.
To do this, OpenAI came up with a new benchmark they're calling GDPval. And you can forget all those abstract AI puzzles. This thing measures how well an AI can do actual work. We're talking tasks from 44 different jobs, so things like creating complex spreadsheets for an analyst, drafting plans for an engineer, or even outlining a legal brief for a lawyer.
Now this is where it gets really interesting. Look at the jump in performance. The last model, GPT-5.2, was already pretty impressive, right? Almost 71%. But GPT-5.4, it didn't just nudge forward. It blew right past that, hitting 83%. And that's not just a minor improvement. That's way above the baseline for actual human experts.
So what does 83% actually mean, like in the real world? Well, it means that when a panel of industry experts sat down and compared the AI's work to a human professional's, they actually preferred what the AI produced in more than 4 out of every 5 cases. Think about that for a second.
Okay, so creating high-quality documents and analysis is one thing, but what about actually using the tools? The software, the apps that professionals rely on every single day. Well, that brings us to the second huge breakthrough.
And for that, we have the OSWorld benchmark. This thing tests an AI's ability to navigate a real computer desktop. It literally has to look at the screen, move the mouse, click on icons, type into fields, to get stuff done. Everything from managing your files to booking an appointment in your calendar.
And this chart just says it all, doesn't it? The previous model, GPT-5.2, really struggled here, scoring under 50%. Your average person? This score around 72%. But look at GPT-5.4. At 75%, it's officially better at using a computer than the average human being. That's a huge milestone.
Now, what's powering all this? Well, it's a massive upgrade to the AI's short-term memory, what we call its context window. It can now hold 1 million tokens of information at once. To put that into perspective for you, that's like feeding it an entire software code base to debug, or giving it 5 full-length novels to analyze, and it can handle all of that at the same time. It could remember an entire year's worth of conversations with you and never forget a single detail.
Of course, this level of power immediately brings up that classic black box problem, right? We see the incredible results coming out, but we have no idea what's going on inside. What was the internal logic? How can we be sure it's not just getting really, really good at faking it?
And yeah, that's the billion-dollar question. When you have a model that's this smart, this autonomous, how on earth do you monitor it? How do you make sure it won't hide some malicious intent or start chasing goals that you never gave it?
Well, believe it or not, the answer is completely counterintuitive. It turns out the key to keeping it safe lies in this built-in and, frankly, kind of clumsy limitation it has.
Okay, to get this, we first need to talk about something called chain of thought. Think of it as the AI's internal monologue. It's the step-by-step reasoning it literally writes out for itself before it gives you the final answer. It's exactly like when your high school math teacher made you show your work. Same idea.
So this led safety researchers to a really critical question. What happens if the AI learns to lie while it's showing its work? So they came up with a new way to measure this, called controllability. And it does exactly what it sounds like. It measures how well an AI can deliberately hide or even manipulate its own internal thoughts.
And the results, they were absolutely stunning. When researchers asked these models to control their final answer, what they say out loud, they were pretty good at it, succeeded more than 60% of the time. But when they asked them to control their internal thoughts, their chain of thought, they failed miserably. The success rate just plummeted to less than 16%.
So this reveals this incredible weakness. For all their power, these advanced AIs are just terrible liars. They can't seem to stop themselves from thinking out loud honestly, even when you tell them to hide something. It's wild. They'll even write down in their own reasoning that they're trying to be deceptive but are failing at it. And this led to a pretty profound realization, which is summed up perfectly in this quote from the research paper. This weakness, it isn't a bug that needs to be fixed. It's a feature, a critical safety feature. Because the AI can't easily hide what it's thinking, it means we can actually trust its internal monologue as a much more honest signal of what it's really trying to do. So this completely flips the script on AI safety. It creates this powerful new dynamic between how capable a model is and how well we can actually keep an eye on it.
So let's break down why this matters so much. First, it makes it way harder for a rogue AI to hide some kind of dangerous plan. Second, it means that looking at its chain of thought is a genuinely reliable way to supervise it. And third, it gives us a sort of canary in the coal mine. It's a clear metric we can watch. If future models start getting good at hiding their thoughts, well then we know we've got a serious problem on our hands.
And because this is so important, OpenAI has now committed to treating controllability as a key safety metric. From now on, they're going to measure it and report it on the official scorecards for all their future big models, right there alongside the performance numbers like GDPval and OSWorld.
So here we are. We've got this powerhouse AI that can do professional work better than humans, but its most important safety feature is a mind it can't fully control. For now, its thoughts are an open book. But the critical question, the one this all leaves us with is, what happens when the next AI finally learns the power of a hidden thought?